Okay, so we're going to review for test 2-3. That is going to be on December 21st, and you have your extra help on December 20th, Thursday. Okay, so for number 1, it says determine if f of x is a factor of g of x. One way that you can do that is by doing long division. So I'm going to take 3x minus 4 and divide that into 6x to the third plus 16x squared minus 11x minus 19. So 3x goes into 6x to the third, 2x squared times. I multiply that out, so I get 6x to the third minus 8x squared. I put that in parentheses and I subtract it. This cancels, and then 16 minus negative 8 gives me positive 24x squared, and I bring down the minus 11x. That is one round. So you just keep going with that until you get stuck with your remainder, until you can't divide anymore. So 3x goes into 24x squared, 8x times. I multiply that out, I get 24x squared minus 32x. Put it in parentheses and subtract it. So then I do, this cancels, and I have negative 11 plus 32, or 32 minus 11, which gives me 21x. I bring down the minus 19. And then I have 3x goes into 21x 7 times. I multiply that out. I get 21x minus 28. Put it in parentheses and subtract it. I end up with a remainder of 9. So I have to rewrite this as 2x squared plus 8x plus 7, and plus 9 divided by 3x minus 4. However, the question says to determine if it's a factor, so I haven't really answered the question. I have to say whether it is or not. So, it is not a factor. And then if you wanted to, you could say, because the remainder is not equal to 0. Okay, you can't say because there is a remainder. You do always get a remainder. It's just whether or not it ends up being 0. Okay, for numbers 2 and 3, we have rational equations. So for these, you're always going to factor your denominators and then put your LCD on top of all of them. Multiply everything by the LCD. So this is negative 3 over x times x plus 1 plus 2x over x plus 1 equals 1 over x plus 1. So my LCD, if I put all those together, is going to be x times x plus 1. I multiply all of the numerators by that, and I have to see what I can reduce now. That way my denominator ends up canceling and ends up reducing to be 0. So my x's cancel here. I'm left with negative 3. Then my x plus 1's cancel. I'm left with 2x times x is plus 2x squared. Here my x plus 1's cancel. I get equals x. So now I have a quadratic equation. So I'm going to set it equals 0 and put it in the correct form. So this is 2x squared minus x minus 3 equals 0. I have 3 options for this. I don't want to do completing the square because that's messy. You actually can factor it though. So this is going to be 2x x 2x minus 3 times x plus 1, so I get x is equal to 3 over 2, and x is equal to negative 1. However, negative 1, if I plug that into my denominators, ends up becoming 0 in the denominator, which I can't have. So x equals negative 1 gets rejected. And my only answer here is x equals 3 over 2. Okay, same deal for number 3. I have a trinomial on the end there, so I have to factor that using master product. So this is 3 over x plus 1. That stays the same. And minus x over x plus 4 equals 3x over, if you do master product on this, you end up with x plus 1 times x plus 4. So then my LCD is very convenient because the two factors on the end there ended up being my other denominators. So it makes it very easy for me. So this is x plus 1 times x plus 4 on top of all of them. And then I have to see what cancels. So here my x plus 1's cancel. I'm left with 3 times x plus 4. Then my x plus 4's cancel. And I have minus x times x plus 1 equals x plus 4's cancel, x plus 1's cancel. I get 3x. So when I clean up this side, I have 3x plus 12 minus x squared minus x equals 3x. This is negative x squared plus 2x plus 12. So I'm going to bring everything to the right side just because I want my x squared term to be positive. So I'm going to put a line here to separate this. So this is going to be 0 equals, if I add over the x squared, I subtract over the 2x, and I subtract the 12 over. So I do master product to solve this, or I could do quadratic formula, or I could do complete the square if I really wanted to, but I end up with x plus 4 times x minus 3. So my two possible answers are x equals negative 4 and x equals 3. However, negative 4 plus 4 in my denominators here and here end up becoming 0, and I can't have 0 in the denominator. That's extraneous. So I cross that out. Okay, because I can't have anything being undefined. And then 4 and 5, absolute value equations. Very straightforward. Isolate the absolute value, set up two equations, and then solve each one and check them. So for number 4, I'm going to add the 4 over. So negative 5 times the absolute value of x minus 5 is equal to negative 20. So the absolute value of x minus 5 is equal to 4. So I set up two equations. X minus 5 equals 4, and x minus 5 equals negative 4. So here I get x equals 9, and over here I get x equals 1. I have to plug these back in and check. You have to be very careful. So I plug these back in, and here I have negative 5, absolute value of 9 minus 5 minus 4 equals 24. I plug it in, and I get negative 24 equals negative 24. It works out. So this is a good answer. Same thing with 1. I do the same exact check over here. I just plug in 1, but I do end up getting that this works out as well. For number 5, so a little bit more difficult is number 5 because you have a binomial on the other side. So this is the absolute value of 4x plus 1 equals 2x plus 5. So my absolute value is isolated, so I have 4x plus 1 equals 2x plus 5, or 4x plus 1 equals negative 2x minus 5. You have to make sure you distribute any negatives. So this is really negative times 2x plus 5 we had done in class. So here if I subtract over 2x, I get x equals 2. On the other side, I get x equals negative 1. And of course, I have to plug them back in. So 4 times 2 plus 1 minus 5 equals 2 times 2. When I plug this in over here, I get 4, which is equal to 4. That works out. That's good. I do the same thing for x equals negative 1, and I also get that to work. So that's a good answer as well. 6, 7, 8, and 9 deal with piecewise functions. So you're just evaluating for the beginning. So a piecewise function is when you have more than one function and you have to choose which domain. You have to look at the domain and see which function you are evaluating it for. So for number 6, I have f of negative 6. Negative 6 is less than negative 2. So I'm going to use this function here. So when I plug in negative 6 into that function, I end up with negative 23. For negative 2, even though this says x is less than negative 2 for this function here, that doesn't include the negative 2. The negative 2 gets included in the bottom one. So when I plug in negative 2 into the bottom, make sure you put parentheses around the negative 2 when you square it, and you end up with 5. And then f of 4, 4 is greater than or equal to negative 2. I'm going to use that bottom function again, and I get 17. So now for the average rate of change, these are my x values, and I'm plugging it in, but I have to choose which function I'm plugging it into again. So I have to do f of negative 3 and f of 5. So negative 3 is less than negative 2. So when I plug in negative 3 into this top function, I get negative 14. And for 5, that is larger than or equal to negative 2. So 5 squared plus 1 gives me 26. So I plug this into my slope formula. I have 26 plus 14 divided by 5 plus 3. This is 40 over 8, which is 5 for the average rate of change. Okay, now we're going to graph an absolute value for number 10. So when x is less than or equal to 3, I'm going to use 2x minus 5. So I have x, 2x minus 5. Again, my table is my work, so be careful. And then when x is greater than 3, I'm going to use the absolute value of x minus 4. Okay, so let's head back to the other function first, though. The other part of the function first, rather. So when x is less than 3, less than or equal to 3, that means that 3 is the largest that it has, and then it keeps going down. So I have 3, and then I would have 2, 1, 0, negative 1. You can do as many points as you want, but it is going to have an arrow facing in that direction. Okay, so take a second now and fill in this table. Okay, so I have these points. I'm going to plot them, and then at 3, 1, I'm going to have a closed circle because this is less than or equal to 3. It includes the 3, and whenever your function is inclusive to a point, it's going to be a closed circle. So I'm going to graph that now. So that is what that piece of that function should look like. So now I have to do the other side. So I have x is greater than 3. I have to start at the domain change, and that's just going to get an open circle because it's x is greater than 3. It doesn't include that point. So 3, and then I could do 4, 5, 6, and 7 if I want. Okay, so I'm going to take a second now and fill that in. And these are the points that I get. So when I go to graph 3, 1, and I go to put an open circle, it already has a point there. So you're not going to see an open circle on top of a closed circle. It's just going to be closed. So I'm just going to go to 4, 0, and then 5, 1, 6, 2, and 7, 3. And this is my graph. Now the reason this has this v here is because this is an absolute value function. Absolute value functions make that v. Okay, whenever you're graphing it, unless you have a specific domain you have to look after, you do want to try to get both sides of the v going. That way it doesn't look like you think it's a linear equation. All right, 11 through 16. So we have rational expressions. I told you guys in class that you can cross out 12 or 11, whichever one you want, so I'm going to do number 11 first. So this is multiplying. So to multiply, I have to factor everything. So x minus 2 stays the same, but the denominator, when you factor this using master product, you should get x minus 7 times x minus 2 times x squared minus 49, that's dots. It's going to be x plus 7 times x minus 7. And on the bottom, I can only do a GCF of x to the third, and I'm left with x plus 7. So when I start canceling things, these cancel, x minus 7's cancel, and x minus 2's cancel. So my final answer is 1 over x to the third. It's not just x to the third, because x to the third is in the bottom. Number 13, we have division. So before you do division, before you try doing something with division, you're going to do keep, change, flip. So you're going to rewrite the first fraction, change the division to multiplication, and then flip this around. So this is now 4x squared minus 1 over 2x squared plus 5x minus 3. So I'm going to factor everything. So 15 minus 3x, that's going to be 3 times 5 minus x over, this is going to turn into 2x (4x squared minus 1 is dots, so that's 2x plus 1, 2x minus 1, that one's easy. Divided by, and then I have another master product. And then I start canceling things out. So I have 2x plus 1, 2x plus 1, 2x minus 1, 2x minus 1, and then 5 minus x and x minus 5, those are opposites, and subtraction is not commutative, so you have to cross them out, and you're left with -1. So 3 times -1 is -3, divided by, on the bottom you still have x plus 3. I cannot cancel the 3's out because they are attached. The bottom one is attached to the x. And then number 14. So I have some multiplication and division combined in here. So the first two, I'm going to do keep, change, flip on the division part. So this stays the same. So I'm going to rewrite this. And then I'm going to do keep, change, flip on this. So I'm going to keep this first fraction, 2x plus 4, over all of this. And then change this to multiplication and flip this around. And now I'm going to do exactly what I just did before for multiplying. So I'm going to factor everything completely and then see what cancels out. Okay, so this is everything factored, and then when I go to cancel things, I have 4x plus 3's, x minus 1's, x plus 2, 2's, x minus 2, and I think that's it. So on the top, I'm left with 5x. And on the bottom, I can't cancel the x plus 1's because they're both denominators. You have to cancel numerators with denominators only, or vice versa. But it can't be two numerators or two denominators. So I have x plus 1 times x plus 1, which I'm just going to write as x plus 1 squared. Same thing. For 15 and 16, I am adding. So let's do 15 first. So I need common denominators. The easiest way for me to get common denominators here is just to multiply them by each other. So this side I'm going to multiply by 2x plus 3 over 2x plus 3. And over here I'm going to multiply both the top and the bottom by 5x plus 4. So this becomes 4x squared plus 6x and I have plus. This turns into 30x squared minus, not minus, this is plus. So I have plus 24x. And then this is divided by the same thing. So then when I add these, I get 34x squared plus 30x over 2x plus 3 times 5x plus 4. And then if I wanted to factor the top to make sure nothing cancels, I can. However, nothing is going to cancel, so if you leave this as your final answer, you would be fine. And then 16, we're adding 3 things. So I'm going to factor the denominator on the end to see if anything is kind of helpful for my LCD. So this is 2 over x plus 3 minus x over x minus 1. And I have plus x squared plus 2. And then this denominator is actually x plus 3 times x minus 1, which is convenient for us. So this fraction, I have to multiply the top and the bottom. This is missing x plus 3. And this fraction, I'm going to multiply the top and the bottom by x minus 1. So this is now, if I go through everything, this is going to be 2x minus 2 minus x squared minus 3x plus x squared plus 2. Make sure that you distribute that negative there. And then this is all divided by x plus 3 times x minus 1. So I clean this up. Negative x squared and x squared cancel. 2x minus 3x gives me negative x. And then those two cancel also, so this is my final answer. And then 17 and 18 are your typical work problems. So Melinda is 7 hours to complete a puzzle. Mark is 10 hours to complete a puzzle. How long is it for both of them? So you're going to have Melinda plus Mark is equal to both of them. So Melinda is 1 puzzle, takes her 7 hours. Mark is 1 puzzle, takes him 10 hours, is 1 over x. My LCD is 70x. Melinda, her fraction reduces to 10x, plus Mark, his fraction reduces to 7x, equals both reduced to be 170. So I get a final answer here. This one's rounded to the nearest hundredth. I should get x equals, I'm not going to go through solving the linear equation, but x equals 4.12 hours. And then for 18, Frankie is 49 minutes. Frankie and his sister, because it says help him, would take a half an hour. So Frankie is 1 over 49, and plus his sister is both. So Frankie is 1 over 49. His sister is what we're looking for. And then 1 over both. You can't say 1 over 0.5 because that's in hours, and then Frankie's is in minutes. So you have to make this 1 over 30. So here my LCD is going to be, I'm just going to multiply them together, and I get 1470x. So Frankie's fraction reduces to be 30x plus 1470 equals, both is going to reduce to be 49x. And then I have a linear equation, so I subtract 30x and divide both sides by 19, and I'm going to get x equals, rounded to the nearest tenth, this wants 77.4, and that is in minutes. Okay? If you have any questions, again, extra help is going to be on Thursday after school. Happy studying.